Hello everyone, my name is Vincent. Today I would like to present to you the journal about IoT-TEG 4.0, a new approach 4.0 for the test event generation. So first of all, we're going to talk about the abstract. The purpose of this article to find out the testing of multiple connected IoT devices that will receive, process, and make decisions according to the complex and real data that travel through the network. Presenting IoT-TEG that is stated for the test event generator 4.0, which is based on the test event generator system. Generation of test event 4.0. Definition of event 4.0. New ways of defining event values are included, allowing heuristic event instances. Creation of the XPR language. This language has been created to define complex arithmetic operations which allow IoT-TEG 4.0 to define events 4.0. Generation of events 4.0 over the time allowing real-time testing. Generation of test event 4.0 that simulate the behavior of IoT system with regard to the time and different data types. It has to be taken into account the frequency of event 4.0 or if sending an event 4.0 triggers the sending of another one. The inclusion of this feature allows a real-time testing. Creation of an IoT 4.0 testing tool, providing usability, a graphical interface that makes testing easier, integrating all the previous contributions to IoT-TEG 4.0. So first of all, we're going to talk about the events. The information transmitted between IoT system is sent in the form of events as follows. Event instance, every situation that may require a reaction from the system. Event type, classifies the event instance and describes their conceptual feature. Each event instance belongs to a certain event type. And also a few other recommendations to define an event type. There's three things. First of all events must be instances of event type. And the second, an event has the structure defined by each type. And the last one, the structure is formed as a collection of event attributes. An event attribute could have a simple or complex data type. So this is how the picture of IoT-TEG event type specification. As we can see in here, we have the event type, which is a name, and from there we can see the block, which is a name, value, or repeat. First of all, the green is properties are optional, and then if you see the optional field is mandatory, and if you go to the field itself, there's a name, quotes, type, value, min, max, precision, length, case, and character. Format is numeric, choose name, dependence. The max diff is equal to 1. And there is an attribute which is the type, value, min, max, precision, length, case, and character. Format is numeric. This is how a certain event is specified in the IoT-TEG. Defining events 4.0. An event type structure depends on the device and components that are connected to the IoT system network. The connected element emit a large volume of information, which is filtered. That filtered data also affect the event type structure. For instance, an event type structure can be composed of the value of filtered data from one or more devices. Considering this requirement, the event type definition has to be abstract and contemplate a variety of options. The greater the abstraction, the more event type definition can be designed. And also the main goal is to generate test event that cannot be taken apart from the ones generated by the original source of the IoT system that is under test. The importance of the events and their attribute has been reflected in several studies, where the relevance and possible purpose are highlighted. Generating events 4.0. There is two things. First of all, times distribution event generation, and the second one is concurrent event generation. So the first one, how it works. So there is a relation between event and one of which is time. To simulate the event that the event producer system would emit, a planification for the generation of the event has to be defined. That planification consists of the following. Period, this attribute describes how often an event will be generated. A delay, this attribute describes how much time of IoT-TEG 4.0 has to wait until the first event is generated. And the last one is unit. This denotes if the last two attributes are in seconds, minutes, and so on. So this is how the picture of generated event works. So for every second, there is some event that is generated based on the time distribution. And so the second one is concurrent event generation. Cause is another relationship, such as for instance event A causes event B to happen. The changes introduced in the previous section have made it possible for IoT-TEG 4.0 to generate a huge number of events 4.0 concurrently without the need for executing the program over and over again for each defined event type. The concurrent event generation algorithm is similar technically to the time distributed generation algorithm, but the only difference is that to allow different event types to be generated concurrently, two or more stacks have need to be added to the pool with the same or different time plannings. So this is how it looks. So it's almost the same like the previous algorithm. But this generation is there is many event that is happen like many times but in different time. So now we're talking about providing usability. Now as you can see from this picture. Okay, so this is how we try to put certain data in the websites. And in the IoT-TEG 4.0 allows the definition of test events without knowing how the event type is implemented or generation of test event 4.0. In order to illustrate how the graphical interface works, we have included the more representative parts in the inside event type. Screens allow for the modification of event type definition, starting the time distributed generation and downloading the generated events to a file. Also shown in the screen that allows for definition of a new field of an event type with regard to its type generation mode and different parameters. So in conclusion, in this article it presented IoT-TEG 4.0, a system that integrated the events 4.0 definition, and a graphical interface that is event generation. The obtained test event 4.0 allow us to be more accurate while testing IoT system. They can mimic the data and enrich Industry 4.0, such as events that are distributed over time, different types of events built with the injection of either value, and so on. IoT TAG 4.0 covers wider number of use cases and different types of tests. So this is my presentation. Thank you.